Hello and welcome to Getting Started with SQL Part 4. This video, what we're going to be doing is going over some more joins, and they are the join or inner join and the left join. There are other joins out there which are appropriate, so the right join, the full outer join. The majority of time that you're working with SQL databases, you are going to be working with the inner and the left joins, and the sole reason for that is, and I actually found a Reddit thread somewhere on this, you can always flip the way joins work, but although right join exists, there are very few situations when you would actually use it. We will be covering left joins, and I will go over the inner join again and the differences between left and inner join. The second piece is going to be around aggregations. So thinking about counting, summing, averaging, you can do median, percentiles, totals. You do all sorts of things with aggregation, and they're basically just rolling up the values within the database. And one of the really powerful things with SQL, and the reason you would want to do that, if you assume for a second the web store example that we're working on, let's say this was a real production database and it totaled into the hundreds of thousands of rows for transactions. If you were building maybe a dashboard page for the web store owner to go into and see the total value of the month's worth of transactions, in the background, what you don't want to be doing is having your application have to sum all of those values up. If SQL can do it, let SQL get on with it. Anyways, I'm going to stop my yapping and we're going to get into the contents of today's video, which is some more joins, so the differences between the inner and the left join, and some aggregations. So as before, I am going to come in and I'm going to create a new SQL script. And let's just take a look. And I'll be honest, if you've not encountered joins before, unless you are just a gifted natural at understanding these sorts of things, this is going to take time. And the best way to understand it is just to write and rewrite and rewrite and rewrite and try and break things in a test environment on your local machine. Try to interrogate the information within a database to the point that you understand why it's doing what it's doing. I will try to explain to the best of my ability why things are doing certain things. But there are so many edge cases. Obviously, SQL, you can write anything you would like. Let's go ahead, and we are just going to start with a very basic query. And the premise of this question is we want to understand how many times each product has been ordered. For this script, I'm going to utilize comments again. So we are going to say how many times has each product been ordered. To start with, we know we have our products table, which contains all of our product information, and we know we have our orders table, which contains all of our orders. We are going to need to be querying from both of these. The keywords are each product has been ordered, product and order. So I'm going to start from the products table because we are going to want a list of products. So select, goodness knows why Ultra just showed up then, from products, and let's alias this products table as P, it says deleting it, p.id and p.name. I typically, as my own things I've picked up over the years, I will always try to capitalize SQL keywords. It makes them easier to recognize from things like column and table identifiers. My preference is also to separate out things like my queries like this, where I am putting each row I'm selecting on a new line. And the sole reason for myself, apart from readability for doing that, is if I run this query and I say, fantastic, got these results back, but I don't want price anymore, I can just come in, I can comment that line out, and it doesn't affect anything else. If this is all on one row, I can put a comment there. But if we've also got p.currency here, I can't then just comment out price without also commenting out currency. So my preference is to list each column on its own line preceded by a comma. The only column I cannot comment out easily then is the first one, but that's just, again, my own preference for how I write queries. So we have all of our products, and the last time we were working in this database, we were using join or inner join. So let's go ahead, and I'm going to type this out in full this time, but we can take a quick look at what it would do without it. Inner join orders O on, and we're using the product ID equals O dot product ID. So we are joining the orders table onto the orders. We're joining the orders table onto the products table. I think I got that right. The products table, because we are joining the orders table onto it, the products table, for the purposes of these Venn diagrams, is on the left-hand side. So on the left, table A is products. On the right, table B is orders. Let's just go ahead and pull in the O.id. Run that, and just to show you, join, inner join, they do exactly the same thing. Join is sort of the default behavior. Inner join is its real name, but inner join and join by itself will do the same thing. The difference comes when you start to specify different kinds of joins, but you can omit the inner if you would like. For readability purposes, it's probably better you put inner though, just so people coming along to the scripts later on can understand what you were trying to achieve. If we come back to this Venn diagram, we can see table A and table B, and the shaded area in red is what is returned. So we are only returning things that are matching within A and B. And what does that actually mean? Well, our orders table has product IDs, and our products table has the ID, the product ID. We are only returning any rows where this statement is effectively true. If we come over to these Venn diagrams again and have a look at the left join example, you will see the entirety of the circle A is highlighted in red. And if I come ahead and change that to a left join and run this statement, this is now going to return everything in table A and anything matching in table B. So we've got everything in table A, iPhone, calculator, pen, toaster, toaster, and order IDs 1 and 2. We should probably alias these as well so they're easier to understand. I've lost my cursor for some reason. And it's back. And it's gone again. I have no idea what my cursor is doing at the moment. That's product ID. This is going to be a challenge. Right, product ID, order ID, and the name. So why is this specifically useful? Well, we want to understand how many times each product has been ordered. And to do that, we're going to do something called aggregation, which we're going to count the number of times that a particular product has been ordered. And to do this, there is a whole page on the SQLite website named built-in aggregate functions. And there are specific ways of using these, but we want to count, and that will take us to here. We can count X or we can count star. The count X function returns the count of the number of times that X is not null in a group. The count star function with no arguments returns the total number of rows in the group. So let's go ahead and try this out. And the way you structure this query is you would place the count around the ID, because we want to count X is going to be the order ID. We want to count the number of times that X is not null in a group. So X isn't null there, so that will be 1. X is null there, so that will be 0. X is null there, so that will be 0. X isn't null there, so that will be 1, and so on. And this is then going to become order count. And I am going to go ahead and run this. And it has not returned what we thought it would. This caught me out because in SQL Server, at very least I know, this statement wouldn't work. What SQLite is doing here is it takes the first row, ID and name, 1, and iPhone, and then order count 2. If we have a look at the wording of this though, the countX function returns the count of number of times X is not null in a group. And the group is important here because we need to group these. SQL doesn't know what we want to group by. So it's just returned the first row because an aggregate is aggregating the data within it. So SQLite is saying, I'm just going to get you the first row and then aggregate. What we want to do is we want to have different groups that we are aggregating by. And in SQLite, what you can actually do is group by is the keyword we're going to use. And importantly, the structure of this is important. Group by has to come after a from, join, and where clauses. But we are going to group by p.id. This also wouldn't work in other database engines I've worked on. Again, SQL Server is what I use most of the time. It would force me to specify p.name as well. I will have to test this out in Postgres when I get a chance. We will be moving on to Postgres later on in this series. Perhaps that's something we'll do. So I'm going to write it out in full as I know it would be done in other relational database management engines. And here we have our results. So we've got the product IDs, we have our products here, and we have the order count. 1 iPhone and 1 toaster. Marvelous. So let's go ahead and see how this would work. Let's place an order for another toaster. And to place an order, place order for another toaster. Insert into orders, and we are going to insert the product ID, the customer ID, with the values. The product ID is product ID 4. We only have one customer with customer ID of 1. We're going to go ahead and run this. Updated rows 1. And let's run this again. And here we go. We have our order count of 2 for toasters. However, if we were to take this query and remove the aggregation, so the raw underlying product order join data, I'm going to remove the aggregation from here. And we don't need a group by anymore. So this is the query that we had before, the product ID, the name, and the order ID. And we run this again. What you'll notice is we have the toaster of product ID 4 appearing twice. And this might not be what you expect, to have this toaster appear twice. But if you think about it from the Venn diagram perspective, here we are joining on the right hand side this products table, product and product ID and name, onto the orders table. That isn't order count anymore, that's order ID, isn't it? That make more sense. There we go. We're joining this onto here, and 2 orders exist for the toaster. So the only way of joining this on is to duplicate this ID of 4. And we could place another order. And as you would expect, this is now going to return 3 rows. And just for completeness, exactly the same thing happens with an inner join. It's just it will return toaster, toaster, toaster with iPhone at the top without the nulls that we were having in the order ID when we used the left join. So we know how many of each product we've sold by looking, or how many have been ordered, by looking at this particular query here. Let's go back to the dashboard example and see if we can't look at what is the total value of orders that have been placed. So total value of orders that has been placed. And by that, I mean we just want one number to come back with the sum of all of the orders. So let's take a quick look at our products table and work out what that should be so that we are able to verify that information. And forget my keywords. One of the important things to do with building SQL queries is always going to be to validate the information that you're returning from them. So just because you've got a particular query, looks fantastic, you've written it all out, doesn't mean that the answer's right. A join can catch you up, a where clause, some conditional logic can catch you out. I have written so many queries, been fully confident in the answer, only to have it completely smashed to pieces when someone pulls it apart. Always, always, always validate your work. So we have one order for item number 1. And what I'm going to do is, I believe, I can just do this, plus we've got 3 toasters. So I'm going to do 3 times 19.99. And that returns 1,158.97. Because this is effectively just returning the sum value of that SQL is able to perform, just maths within its columns. So we know what this has got to be. I will remove that and I will comment that out at the top, just so that we've got that. So let's see what we want to do. We want the sum. Where have you gone, sum? Notably in SQL, you can also use total. Total will always be a floating point value, but sum is an integer value if all non-null inputs are integers. Sum is what I've used in other engines as well, so that's what I'm going to go ahead and use, but feel free to experiment again with total as well. So sum and total aggregate functions return the sum of all non-null values in the group. If there are no non-null input rows, then sum returns null, but total returns 0.0. So we are summing the total value of the orders that have been placed. So select from orders, and we want to take the sum, alias that as O, we are going to want to take the sum of each order. Now to get the sum of each order, we are going to need the price. So I'm going to join products P on O.product.id equals P.id. And then we have access to P.price because the P.price is the X in this. And that should just work, yes, because each order only has one product. So we don't need any group by here because we're not grouping by anything. We are just able to sum the value of all of the prices that relate to each order. And we can have a look at the raw data for that as well. So let's go ahead and select O.id. and p.price. So all that is doing is summing p.price. We're not returning order ID. We are just summing all of these values. And that is what this particular function here is doing. Now, I got caught in knots earlier on, and I'm going to give this another try and see if I can't debug why I got caught in knots. I was summing each of the order counts, and I wanted to work out how much had been sold for each product. So to do that, I can do count o.id times by p.price. And in theory, I think that needs to be an aggregate as well, because we are summing the value of p.price. This returns, we've got 3 orders for, what was the value of the, let's just pop that in here, price, and group by p.price. This is the total order value. Total orders value, because we're taking multiple orders. Now, the keen-eyed amongst you will notice that 19.99 times 3 is not 179.91. And what this is doing, I believe, in the background, and this is where joins can really, really, really catch you off guard, because if we removed this group by, what's the best way of doing this? This is just going to return me one row. 4,000, that is very clearly wrong. This ultimately has 3 orders beneath it, and I believe the value of this is basically going to be 3 times 3 times 19.99. Let's double check that. 3 times 3 times 19.99. Yes, 179.91. In the background, what's happening is there are 3 rows that exist for this row 4. We've just grouped them. So this is doing 19.99 times 3, 19.99 times 3, 19.99 times 3, and it is summing all of those together to get 179.91. And this was very clearly wrong. So what we want to do is actually work out the product ID, the name, the price, the order count, and the total order value. So I think I've got an idea as to what we want to do. We know this is returning 19.99 times 3, because we are doing 3 times the price. There are 3 of these rows in existence. Therefore, we want each row just to represent one order. So what we can use, there's another function in here called max. So why don't we go ahead and replace sum with max? And that is going to return 3 times the maximum of price, 59.97. Yes, that looks to be right. Okay, so in conclusion, I think this was a video I went into knowing it was going to be complex to try to explain, and I don't anticipate anyone to come away from this, from after watching this, with a moment of clarity. The important things are going to be syntax, making sure that you have these statements in the right order. So select from joins where statements, so you're able to still add those, where p.id equals 1, for example, like so. And then group bys come after that where statement. There are other things that can come into these queries as well. I'm not going to go into those yet and confuse you, but the joins really are fundamental to really harnessing the power of SQL databases, because the relational database, the relational nature of these relational databases is what makes them ultimately really, really powerful to use in production systems. And you come into something called normalization, which is where you want to basically minimize the amount of duplication within databases. Again, a topic for another video. Perhaps I won't even attempt to cover that one because it's an incredibly complex topic. However, I do hope that this has been of some use, even if it is just that we are starting to work with some very simple joins on some simple tables that you've created. Out in the wild, there are some very large, nice demo databases you can download and play with. They're much more complex when you haven't built them from the ground up. I think this, you know the data that's in your database, you know how your tables are structured, and you've built them by hand yourself. So you know how it all fits together, and that gives you the opportunity to go in and experiment with what happens when I put a right join here versus a left join versus an inner join. What are the differences that are going to come out of it? Keep referring to the Venn diagrams. Other examples are out there. This was just one I have picked out in particular. Keep referring to the documentation. Try out your averages, try out your counts, try out your max, medians and sums, totals. Have a play around. The SQL statements are never going to, if you're using a select, as long as you're not doing a select into, you're never going to be altering the structure of the database. And SQLite will happily throw you an error when it doesn't know what's going on. So hopefully you found this useful. Again, I don't expect anyone to have come away new to joins and aggregations and to be like, oh, well, I know exactly how these work now. These are very, very, very complex topics. And when I was learning them, there was a whole lot of maths that was taught behind it as well. There is a lot more to it than just a couple of keywords. But on the flip side, the more you do it, the more you experiment with it, the more you try things out, and the more you try to understand it, the more it will make sense. Even someone who's been doing it over 10 years, I still get caught out by, there's a new database I'm working in, and there's a particular data format or structure in place, and you will do a join, and it just does not return what you thought it would. That's absolutely fine as well. It's part of the journey in building that final query which returns the data you want, is all of the fun of it. With that, very talkative video this time around, a lot less code comparatively to, I think, the other videos. I am going to stop this recording here. Please drop any comments in the comment section below, any questions that you might have, and I will continue this series on with some more examples. I think soon, perhaps not the next video, but soon we're going to try and move this over to Postgres, and I'll show you some quick and easy ways of getting started with that as well. Thank you very much for watching, and I will speak to you in the next video.